For a spar gear with a pitch diameter D is equal 50 millimeters and normal model M is equal to 4.5 millimeters and given manufacturing accuracy 877 BA, it is necessary. 4.1. Choose sets of controlled parameters for norms of kinematic accuracy. Norms of kinematic accuracy on first place. Precision in involute tools profile deviation. Smoothness in second place. Smoothness, precision in position of teeth, and contact of teeth in third place. Precision in tooth face helix deviation. 4.2. Based on the selected accuracy indicators, determine the numerical values of tolerances and deviations. 4.3. According to the specific type of conjugation for the side clearance and the degree of accuracy according to the smoothness standards, select the numerical value of the smallest displacement of the original contour. 4.4. According to the given type of tolerance for the side clearance and the tolerance value for the radial round, run out of the gear rim, determine the numerical value of the tolerance for the displacement of the original contour. 4.5. Choose measuring instruments to control the set of controlled parameters of the gear. 4.6. Show schemes of control of the selected parameters of a gear wheel. 4.7. Make a drawing of the gear on A4 format. So we start this task. For a strain-toothed cylindrical gear with a dividing diameter D is equal 50 millimeters, diameter D, pitch diameter D is equal 50 millimeters, normal model M is equal 2.5 millimeters, and given manufacturing accuracy of 877 BA, we choose a set of controlled parameters for the norms of kinematic accuracy, smoothness, and contact of teeth. To control the kinematic accuracy, we choose, taking into account the given degree of kinematic accuracy, 8. Kinematic accuracy in the first place in this task. So kinematic accuracy class is equal 8. So a set of indicators F suffix RR and F suffix VWR. We choose these two parameters to control the kinematic accuracy. You will choose these parameters too in your variant of coursework. Use these parameters too. To control the smoothness of work, on the second place, class of accuracy. To control the smoothness of work, we take a given degree of accuracy of smoothness of work 7, and the value of model M is equal 2.5 millimeters. Set of indicators small f suffix PBR and small f suffix FR. You need to choose these parameters too in your variant of coursework. To control the contact of the teeth in the transmission, taking into account the degree of accuracy of the contact in the third place. First place is kinematic accuracy, smoothness, and third place is degree of accuracy of the contact. So, taking into account the degree of accuracy of the contact 7, we take a indicators of the total contact spot. For the selected indicators of accuracy, we determine the numerical values of tolerances and deviations. For a given degree of kinematic accuracy, we have kinematic accuracy degree 8. For a given degree of kinematic accuracy, big F suffix R is equal 45 micrometers and big F suffix VW is equal 28 micrometers. For a given accuracy of smooth operation, small f suffix PB is equal plus minus 14 micrometers. F suffix F is equal 11 micrometers. And for a given degree of accuracy according to the norms of contact, it's equal 7. The relative size of the total contact spot is equal the height of the tooth not less than 45%, the length of the tooth not less than 60%. So the height of the tooth not less than 45% and the length of the tooth not less than 60%. So when you will do your variant of coursework, you can use this numerical value of this parameter too. According to the given type of connection on a lateral backlash and degree of accuracy according to norms of smoothness, we choose numerical value of the smallest shift of an initial counter. For the type of connection B, taking into account the degree of accuracy of smoothness 7 and dividing diameter is equal 50 millimeters, the smallest additional offset E suffix HS is equal minus 140 micrometers. According to the specific type of tolerance for the lateral clearance and the value of the tolerance for the radial bedding of the toothed crown, we determine the numerical value of the tolerance for the displacement of the output circuit, big T suffix H. For a given type of tolerance, to connect to our lesson, is connecting to our lesson. For a given type of tolerance for lateral clearance, small a, given type of tolerance clearance for lateral clearance A, taking into account the tolerance for radial bedding, F suffix R is equal 45 micrometers. We find the tolerance for the displacement of the output circuit big T suffix H is equal 180 micrometers. And we must choose measuring instrument to control all Z parameters what we find in previous slide. So we choose measuring instrument to control the selected parameters of the gear. For control of big F suffix RR, we will accept betting meter of the B10M model suitable for control of wheels with a module from 1 to 10 millimeters. Our module M is equal 2.5 millimeters. So we choose this measuring instrument because he can control the wheels with the model from 1 to 10 millimeters. And there are the scheme of radial beating control scheme F suffix RR. There are the gear, controlled gear, element of original contour we have, and we use the indicator in this measuring instrument. So we controlling radial bearing control parameter F suffix RR. For control of F suffix VWR, this parameter, parameter F suffix VWR, VW without R, or FVW with R. So we will accept a normal meter of the BV 5045 model that allows to measure length of the general normal to W is equal 120 millimeters. Let's calculate the length of the general normal. There are the scheme of control of fluctuation in the length of common normal, FVWR. And there are parameter W maximum and W minimum. It's the length of the general normal. W is the length of the general normal, is equal W with suffix 1 multiplied by M module. Module is equal 2.5. W suffix 1. For a whale with a given number of teeth is equal 20. Number of teeth. In our task, number of teeth is equal 20. Determine the length of the general normal, W suffix 1, for a wheel with a single module. The values of W suffix 1 and Z suffix N placed in the middle column are preferred in the directory. For Z suffix N is equal 3, number of teeth covered, W suffix 1 is equal 7.66043 millimeters. In your variant, you must choose Z10 is equal to 32. So W1 will be equal 7.66043 millimeters. Then the length of the general normal, 7.66043 millimeters, multiplied by model 2.5 millimeters. And we have 19.15 millimeters. 19.15 millimeters. And there is a scheme of control of fluctuation in the length of the common normal big F suffix VWR. There are the length of the general normal minimum and the length of the general normal maximum and minimum. And that is the measuring instrument for control of the length of the general normal. And we use number of teeth covered 1, 2, 3. Z suffix N is equal to 3. 1, 2, 3. Number of teeth is equal to 3. There are 1, 2, 3 teeth. 1, 2, 3. Zn is equal to 3. Next slide. To control small f suffix PBR, we will accept the pedometer of model 21501, suitable for modulus that m is equal from 1.75 to 10 millimeters. Our model is equal to 2.5 millimeters, so this measuring instrument is usable for our gear. There are schemes to control the deviation of the main engagement step. We have actual tooth profile and nominal tooth profile, and this distance between actual tooth profile and nominal tooth profile, big P suffix BR minus big P suffix B, is equal deviation of the main engagement step, small f suffix PBR. And we choose the measuring instrument to control this deviation. The control of small f suffix small fr can be performed using an environment evolventometer model BV 5032, suitable for monitoring wheels with an outer diameter from 20 to 400 millimeters and a model M from 1 to 16 millimeters. Our diameter, outer diameter, we have 50 millimeters. It's between 20 and 400. And our model is equal 2.5 millimeters, is between from 1 to 16 millimeters. So we use this evolventometer model BV 5032. There are schemes for controlling the error of the tooth profile F suffix FR. There are basic circle. There are actual tooth profile. This non-linear line, it's actual tooth profile. There are between two nominal involutes. First nominal involutes and second nominal involutes. And this distance is active tooth surface. So we must find F suffix FR, the scheme for control error of the tooth profile. Error of the tooth profile. This distance between two nominal involutes. Between these two nominal involutes is actual tooth profile with errors. Checking the total contact spot can be performed on a test running machine. The magnitude of the actual offset of the output contour of the tool can be determined by the offset tooth gauge model 2301, suitable for monitoring wheels with model from 2 to 10 millimeters. And there are schemes for controlling the total contact spot. By tooth height, HM and HP. Under the line is HM, above the line is HM, under the line is HP, and multiply by 100%, it will be parameter by tooth height, and parameter along the length of the tooth is equal A minus C, above the line, and under the line is B, multiply by 100%. Its parameter along the length of the tooth. So we use this measuring instrument to for controlling the total contact spot. And what we show the schemes of control of the selected parameters of a GFL is we will do it. And the last 4.7 make a drawing of the gear on A4 format. The drawing of the gear on A4 format. There are the gear, diameter of the gear 50 millimeters. Module is equal 2.5 millimeters. Number of teeth 20 teeth. Normal original contour by the GOST 1375581. Displacement factor 0. Degree of accuracy 877 BA. 877 BA. Common normal length W. Common normal length. The length of general normal. W is equal 19.15 millimeters. So common normal length W is 19.15 millimeters. Pitch diameter small d is equal 15 millimeters. So there are the drawing of the gear with these parameters. That's all. Have you a question? About the task number 4.